Okie dokie, I need to set a timer. Hopefully we'll get this done in the time. When I first looked at it I was like, oh fuck, but actually now I've slept on it, I think I've got an idea. You can probably tell when I'm recording different streams based on the fact I'm wearing clothes and you can hear the rain. But yes, this is just after Blueprints Day 3 and 4. So, now we need to work out how to get from point A, specifically you, to point B, specifically San. And we're not actually going to orbit San, we're just going from where we are at K to where Santa is at I. So that would be a jump to J, E, D, and down to I. Now, in the current map I have a head node which is com, and everything is a string, and nothing knows what's ahead of it. So I think the easiest way to do this is make an ordered set of objects from com to u, make an ordered set of objects from com to san, find the last common object, and then just count from there down to u, and count from there down to san. Cool. So, what this would look like then, this example is over on the right, is going to be com, B, C, D. Right. Well, this object order is going to be com, B, C, D, E, J, K, and then U. This one is going to be com, B, C, D, I, San. The last common object then is going to be D, and we count from the last common object to U, not including the U. So that's going from, basically, it's this, so it's going to be E, J, K. The last common object to San, that's going to be the I, and then we add. So, we're going to be given a head, which is a ref orbit node, and return nice size. So, having actually thought about this, this is going to be a bit harder than I wanted it to be. Get child node, because we need to do a depth first search. Yeah, okay. So what we're going to have to do is we're going to do a DFS, depth first search, create set as we go. A recursive depth first search isn't going to cut it. Effectively what I want to do is build a list of the parents of a node. So I guess what I could do is we've got ordered sets in Rust. And it doesn't actually need to be an ordered set, it could be a vec of refstir. In fact, vec of refstir is probably going to make life a bit easier. So let mute u. It's going to be a vec of refstir, and that refstir is going to be the ID. And let mute san also vec refstir is vec. No, the reason I wanted to use an ordered set is to easily find common values. But okay, let's see what happens. And let's make it. Oh, you know what I could do? So I could do a then target is going to be a ref star. It's going to return a vec of ref star. It's going to return an option vec of ref star. And this is going to be some recursion magic, which is going to be, it's also going to take, it's going to return nothing. It's going to take a result, which is going to be a vec of ref star. Okay. So, find parents is kind of a bit wrong. It's not finding its own parents. It's labeling itself. So first off, if self.id is exactly equal to target, then push our own self.id. Result needs to be mutable. New result. These need the same lifetime, right? This is a ref tick A. This is a ref tick A. And we're generic over tick A. Do I need to put it in the import, or are we good there? Okay. So what we're just saying is that all the references in our vector live at least as long as self does, or at least as long as the reference to self does, which is fine because you know, once self goes away, which has its own ID, then we can't use that ID in a vec of it, right? Because the ID will get dropped. So, if it's target, push and return. Right, so this is now, we've got down to U. Actually, I only want to do this for the child, don't I? This is easier. This is easier logic. This is fine. This is going to be a recursive call. So now it returns. This vec has something in it. And we're going to say if result, if not result is empty, then result push self ID and return. So basically we'll come down the tree, we'll come down this tree, and we'll get to U. And U is the target, so we're going to push U in and return. Then we get back to K, and K is going to say, well, hang on a second. There is a value in the vec, so we found U, so I'm going to push myself in and return. We'll return to J. J will push itself in and return. E will push itself in and return. D will push itself in and return. C will push itself in and return. So on and so forth. Otherwise, so this is now on the way back up. So we found U. I'm going to go back up. And we now need to make sure we're going down. Otherwise, if it's not, those are our early returns. If let sum children is equal to self.children, for child in children, child dot find parents with target and result. Use of moved value. Oh, yeah, this is wrong. Okay, sorry. So I'm giving ownership of this vec to this. I actually want it to be a ref mute vec. There we go, that's better. Because otherwise I was moving result into this call and then it doesn't exist anymore because it's not returned. So, if we've got to Santa, or sorry, if we've got to U, then we pop U on, we start walking back up and we get this list. Otherwise, we're at com, so both of these checks have failed, and we'll find all the children of com. Go back to the diagram. We find all the children of com, which is B. Right, B is not U, and the vec is still empty. So now we go into the children. So we'll go to G and we'll go to H. Both of those things fail, the function will return back up. Then we'll go down to C, which will go to D, which will go to E, J, K, and U. Return, 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 return. That's the theory. So let's test that. Test, find parents. And I'm gonna, instead of using this list, I'm going to use the no, I'm not creating dominoes, that's fine. So we'll do this on the real list. So we'll go grab input data, and we're going to use day 6 part 2, test input string, and I wanted you as well. That's not my node. Let res be test data dot find parents, and we're going to look for. I need a result. So yeah, that's let mute res vec. This has side effects. Target is U and res. You're going to tell me you needed a reference? Yeah. Expect the vec, and we're going to go in reverse order, so it's going to be U. I probably should have done SAN, that would be faster, but U. KJE, K, J, E, and then I think it's just D, C, B, and com. Let's go fix this. You can turn to 0. One failed, which is part 2 itself. That's fine. That's not done. Specifically, find parents has succeeded. Now, everything else is not related to the node itself. So, compare list is going to take a U list, which is a vec ref stir, and a SAN list, which is a vec ref stir. Shall I just do this straight up in part 2? Which way are these lists going to be? They're going to be in reverse order. So I kind of do want to make these tests, but I can iterate actually and say, does the other list contain that? No. Does the other list contain that? No. In fact, yeah, that's a pretty fast way of doing it. Count list. It's going to return a nice size. So actually this is just part 2. This doesn't need to be a function at all. So we are going to do head.findParents on u with u, and head find parents. The target here is going to be San and San. Okay. Let's. So now we want to do u iter map each value. Do we want to fold? Yeah, so we're going to fold. So fold is going to accumulate stuff for us. So it takes a function which has an accumulator and a value. The value in this case is going to be a stir, which I'll call S. It needs an initial value of 0 because we're doing a sum. Ooh, okay, so yeah, I'll take the other way around. Cool. And it's going to be if san contains, if not san contains S, then ACC plus 1. Otherwise, I need to return ACC otherwise. ACC is not intelligent in any way, else ACC. Okay, let u count equal that. And I need to subtract 1 off this because it's going to say, well, does u exist in San? No, it does not. Does k exist in San? No, it does not. Does j exist? No, it does not. Does c exist? No, it does not. Does d exist? Yes. Stop counting from there. But we need to not count u. There is a more intelligent way of doing this, but this is much faster. And then we just do exactly the same thing again, but if u contains, if not u contains, and it's going to be San Deuter. Okay, so this one is going to say, San, does u contain San? No, it doesn't. Add 1 on. Does it contain I? No, it doesn't. Add 1 on. Does it contain D? Yes, it does. Ignore it. And then we need to remove 1 for the I. And then the result is going to be, I'll name these properly, u count plus San count. And it is unhappy because expected ref. Okay, fine. There we go. Still unhappy because why? Well, up here. Needs to be a ref mute. Okay. Borrow checker keeping me honest. Okay, so test part 2 failed. The left side was 54. I think that's what it said last time as well. There's no way the left part could have got to 54. Test part 2. It's reading day 6 part 2. Okay, I think the easiest way to do this is just going to be a bit of debugging. We're getting to the end of the timer. Oh, I didn't want to. Oh, we've panicked. What? Why are we panicking? What panicked? Oh, the test. Right. We never got to part 2, that's why. Okay, right, still failed, because we got a 1 instead of a 4. So now let's actually go and debug that. What are we panicking in? Day 6 part 2, but I have a breakpoint in day 6 part 2. I don't have a breakpoint in day 6 part 2 anymore. Okay, let's try again. There we go, that's better. So, two empty things. U is U, I, and G, which is incorrect, I think, because U goes to K. So how have we ended up at I? Let's step in for Santa and see what's happening. So we start at com. And neither of those pass. So the child now is B. Let's step in. F11, sweet. So now we're on B. Result has a size. Okay, that's better. The target is San. So we've got some children. For child C, we're going to try and find parents. Now child C does not contain San, so this should be pretty quick, right? Child C does contain San, right? We go to D and then we split at D. So skip those. For each child, child is D. Let's step in again. And then we go to E. Right, E does not contain San, so this should work its way down. And then it's going to... Right, yeah, okay, sorry, so child is F. Right, we're returning out of that. So now we are at E, child is F. And we've got back to E. We return, we're now at D. And child is going to change to I. So we can step in. Those aren't correct, but now child is San. We can step in. ID is correct. Result.push. We come out. Yeah, I know why. Well, kind of I know why. And it's that after I've done child.findParents, that's when this call needs to go in. Right? Because... Yes, that should... There we go. Right. Day 6 part 2 is apparently 0. Is that because I forgot to... Yeah, it's because I forgot to use it. Part 2, ref head. 307. Inevitably, something will be wrong with that. I'm uploading blueprints days 3 and 4 at the moment, which is why this is so slow. Success! That was nice and easy. That only took 4 or 5 videos, and hopefully that was reasonably explanatory. I must say, so previously in Advent of Code, I've effectively done tests manually by having sort of up here in run, doing this twice, and if it runs on the test data and succeeds, then it'll proceed on. I've got to say, I really like the way of doing it with tests in Rust. The way tests work, at least for things like this where it's quite small, it just works so well, and being able to really quickly just go and test a private function and be like, right, this one function should do this thing is quite nice. Obviously I've not had to do any dependency injection or mocking or anything like that, and I haven't done integration tests, so, you know, how easy that is TBD. But for whipping up a quick test, just I'm going to write a function and then a quick test on a private function. It's just so fast and so nice. Cool, that's day 6 done, and there is the timer. So here's a quick note. You may have picked up on, if you were paying attention, my tests were passing. I know I've just said how fantastic Rust tests are. My tests were passing because the way you fail a test in Rust is to panic. And I had just completely forgotten to do anything. There's no assertion here. And so the test doesn't panic, therefore it must pass. And the compiler will warn me, and it's just saying, you haven't used expect. It's not warning me that your test isn't doing anything sensible. And I have a lot of compiler warnings because I've got a lot of dead code that I should go and allow because I've commented out days 1 and, well, all the days that aren't day 6. And so I was just ignoring those, and eventually I was like, nah, I'll go fix the yellow squiggle. Yes. I mean, the test is passing. So it's fine, but this is a small flaw. This is more of a PEBKAC thing, and I don't think any other tests frameworks, I don't know how other test frameworks know, but I assume they would probably fall foul of the same thing. Hopefully that'll be picked up in a PR. But, yes, that's embarrassing.